Howdy, gang. Welcome back. Today is our last class meeting for the test. So I would like to kind of open the day up a little bit to work on sort of whatever you guys want to work on. We'll take a quick look and make sure we've covered all the little things that we need to cover in the detail that's necessary. But as long as we have, and I believe we have, then we can spend today just reviewing, kind of doing whatever you guys would like to do in preparation for the test. So homework problems, study guide problems, anything like that that you want to take a little look at would be good. So in these few minutes, while I kind of look over the syllabus and make sure there isn't anything that we've missed, please go ahead and simultaneously take a look at your notes, your homework, stuff like that, and see if there's anything you would like to work on today. I do see in the chat. Oh, yeah, good morning. I also do want to talk to you guys a little bit about the testing center. If you're going to take the test at the testing center, they have sort of moved their policies around a little bit and do things slightly differently than they used to, which means we have to kind of move our stuff around to accommodate. So let's get that out of the way. And then there was a question about the study guide there I saw. Yeah, I would say if you can work the problems on the study guide without any hassle, then you're in good shape for the test. Most of the problems on the study guide are about the level of difficulty that would be on the test. Some of them are a little longer. Some of them, like that number 17, where you have to find the two tangent lines that pass through that point. That's a little tougher than the test problem would be, but I'd say the rest of them are pretty representative of the difficulty on the exam. So if you're good with the study guide, probably you'll be good with the test. All right, I see Talia wants to see number 5 from the 3.2 homework. I'll pop that up just to get it ready. And then we can come over here and do the thing. Let's just take a quick look at seeing our syllabus. So yeah, we've talked about all the differentiation rules, the chain rule. I wouldn't mind getting a little bit more practice with the chain rule. So there's some where you have to go like 3 or 5 layers deep into the chain rule. I don't think we saw any of those last week. So let me do 1 or 2 more problems from section 3.4 on the chain rule, just to kind of button that up neatly. And then I'll move to homework questions. So Talia's got the first one in there, number 5 from the 3.2 homework. If anybody else has other problems from the homework or study guide they want to see today, go ahead and type that into the chat, just like homework 5, problem 7, or homework 3, problem 2. You know. All right, I'm going to switch over to the dot cam and get us moving. That's not the dot cam. And oh yeah, we need to talk about the testing center stuff too. So I'll put that in here as an announcement. As always, this is MAC2311. The section number is 0H1, which means this has got to be Calc 1 honors. Today is the 27th of September, 2021. So some announcements. Of course, exam 1 is Wednesday. (9:29), and you can do it at the testing center or online. Zoom on your phone and analog on your PC. So if you take the test at the testing center, you won't have to sign into Zoom on your phone or do the honor lock stuff. They just proctor it in person and it's like a regular Canvas quiz. The following things have changed at the testing center. So it used to be the case that I could ask you guys to scan your, if you take the test at the testing center, you scan your written work after you're done there at the testing center and submit it like normal. Unfortunately, they don't allow phones even in the building at this point. Like, you're not allowed to bring a phone into the testing center room, which means obviously you cannot scan your written work. The reason for that is people are being shady. People are like taking pictures of other people's tests or taking pictures of their tests that they just finished and sending it off to other folks. No scanning your own work. I'll pick it up instead. First, you still need to show all of your work, right? Remember, it's the written work that I grade there. The answer you type in the box is just to show me that, like, this is the answer you came up with during the test. But the written work is where pretty much all the credit comes from. So you really, really, really need to show your work, make sure your work is clear, right? Make sure I can read it. I know we don't all have perfect handwriting. I don't have perfect handwriting, but do your best to make sure it's readable, right? Because if I can't read the work, if I can't follow the work, then I can't give you partial credit. And if there's a mistake, then we're in trouble. It goes deeper than that too, right? Like, not just partial credit, but the way that I write these rubrics, each problem has like a few critical steps, and I give you a couple points for getting to that first critical step, and then a couple more points for getting to that next critical step. So I really need to see work for the free response problems. Make sure you're writing it in a way that it can be read. Other things, they're very low on staff. My understanding is that they have 2 people working there right now, which is friggin' impossible. So there may be a wait time. To accommodate this, I am allowing the testing center to give the test anytime on Wednesday. All right, so if you're taking the test remotely, if you're taking it with me here online, then you'll still need to take it during class time, right? It will open at 11 a.m. You got to be here on your phone on Zoom at 11 a.m., get the okay from me and slide in and get it done. If you're taking it at the testing center, you can take it anytime after 11 a.m. So I shouldn't say anytime on Wednesday, anytime on Wednesday after 11 a.m. So, you know, if you get there and they're super busy at 11 and they say you can't take it right now, we don't have enough people to watch you, they'll give you a number like you get at a deli, and they'll ask you to sit around for a minute. There's a few things you need to consider there. First, the obvious thing is, like, since our tests are supposed to be during class time, am I gonna lose time on the test? No, I'm not gonna lose time, because I'm opening up that testing window, so you'll get 75 minutes from whenever they're able to get you started. The other thing is that if you got to sit there and wait for an hour and then spend 75 minutes on our test, that might eat into the next thing in your schedule for the day, right? If you've got another class right after ours, you have to work right after class, anything like that, you want to take that into account. The good news is that, you know, if you have another class right after ours, then you can come back to the testing center at like 2 p.m. Right? If they say you're gonna have to sit and wait for an hour, like, oh shit, that's gonna eat into my next class's time. Come back after that next class. Just talk to the staff there and make sure that you're planning within their hours. And you can take the test anytime after 11 on Wednesday if you're doing it at the center.
What are the hours for the testing center?
That's a good question. They change, which is why I specifically avoided giving quantitative information there, but let's take a look. So hours of operation, Monday through Thursday, 8 to 8, Friday, 8 to 5, weekends 2 to 6. So 8 a.m. to 8 p.m. So on Wednesday, you can take the test at the testing center anytime from 11 a.m. to 8 p.m. Obviously, you show up at 7:59 p.m., you're going to get all 1 minute on the test. So, you know, anytime between 11 a.m. and 6:30.
Is it located at in N 216?
Yes, it is. Yeah, so that's building N, which is on the far southwest corner of campus, kind of over by the running track, the 440 track. It's upstairs, so there's a big door, like a double doors on the bottom floor there, and you go up the stairs. As soon as you come in the door, there's some stairs, go up the stairs, and the testing center is the first room you'll see when you come out that stairwell. Okay, other things that you should be aware of. You need either your Santa Fe photo ID or a government issued ID. So either like a driver's license, state ID, or your Santa Fe ID. The other thing you're gonna need, you gotta know your SFID number. So if like you're bringing your driver's license, make sure you remember your SFID number. So need that as well.
Before I go to there, do I need to ask you help me to book a exam?
No,
Time.
not anymore. So the way I used to do this, I would make individual reservations for each of you at the class time, but they've asked me to not do that because they don't have enough staff. So instead of sending you all there at the same time with individual reservations, I've made a general walk-in reservation. So anybody from this class shows up between 11 and 8 on Wednesday, you will be allowed to sit down and take the test. You don't need to make any specific reservations anymore. And I've already made the reservation for our class, so you're good to go. William asks, can we take the test tomorrow? I'm afraid not. So this is kind of, this is a me thing, being a little lazy here. So every time we split up the test into different ways and times people can take it, I have to create a new version. So there's one version for people taking it online with me on Wednesday. And then there's two versions for people taking it in the testing center on Wednesday. So rather than making a third version of the test, I'm going to say those are the only ones. So we can't do it early. You can do it anytime after 11 on Wednesday at the testing center, or you can do it right at 11 online here with me. But those are going to be our only options. All right, are there any other kind of procedural questions about the test?
So if I wanted to take the test online, would I have to do it at Santa Fe? Where would the best place to do that be?
If you're going to take the test online, I would suggest anywhere you can have like consistent internet access and a quiet place. So at home is fine. At a study room in the library, I think maybe would be acceptable if they allow that. If you're going to do it on campus, just make sure you have a space picked out where you know you won't be disturbed and where you know you'll have good internet. I did have somebody working on their test from a picnic table on campus yesterday in one of my other classes. But that particular picnic table was in a place on campus where the Wi-Fi came in and dropped out, and that caused her a lot of trouble. So make sure you kind of check out the spot you want to use ahead of time. Make sure it is both quiet and has consistent internet access. Are you asking because you need help getting to campus, or is it just you just want to have someone to walk there with?
I just want someone to walk there with.
I see. Okay. Looks like Rhoda's going to be there around the same time. Rhoda, do you want to meet up with Yiping so you guys can walk there together? It's in building N. I'll show you on Google Maps. This is private. Oh, what are you doing? Oh, this is special. Satellite. Here we go. So here's a map. This is Santa Fe. It's not really near the gym. So the gym is way over here. The testing center is over here. Here's layers. Yeah, let me turn on. Right, all right. So when you come to Santa Fe, like here's 83rd. This is the road that runs right out front of Santa Fe. Here is the little bell tower thing. The library is over here. The P building where the math office is right here. Right, so the Learning Commons is over here. P building, math office is over here. This little walkway you see right here is the big covered walkway that kind of runs from building A. Building B is over here. The place where they serve Krishna lunch is like right here. The testing center, right here. It's this big building at the end of that walkway. That's building N right there. You see these triangles here? This is the stairwell in building N. So you'd park kind of back over here, or if you want, over here by the running track, and then walk up here to this hallway, and then look for this big building and go up those stairs, and the testing center is the first thing you'll see after you pop out the second floor stairs. All right, what am I missing in the chat? All right, any other questions about test procedures, stuff like that?
How many questions in the test?
14 questions altogether. There will be 4 true false questions, 4 multiple choice questions, and then 6 free response questions. I'm sorry, is that? Yeah.
Are they all worth the same amount of points or?
No, so the true false questions are worth 4 points. The multiple choice questions are worth 6 points, and the free response questions are worth 10 points each.
Gotcha.
I have a question. What is the response? Sorry, the last questions. What kind of? I don't know what kind of the questions it look like. The 10 points each. That one.
Those questions are very similar to your homework questions, like find the equation of the tangent line, or calculate this derivative, or find the velocity at this time. So those will be very similar to the homework questions.
Okay, then.
Nikita asks, how long will the test take? Test is 75 minutes unless you have some accommodation altering the time. If you do have any sort of accommodation, whether it's through the DRC or elsewhere, please let me know so I can add time in. But otherwise, the test is 75 minutes or 1 hour, 15 minutes. All right. So let me come up here. I've got, I think, 2 problems so far. Problem 5 from 3.2. Numbers 11 and 17 on the study guide. Okay. And then we want to look at some true false type stuff too. All right. Just to give you a feel for the true false questions, here's some examples, right? So I could ask you true or false. The derivative ddx of e to the pi is e to the pi, or true false if f is continuous at x equals a, then f is differentiable. At x equals a. True false. Yeah.
The first is false, the second is correct.
Yep.
Second is false too. Differentiable is a more strict
Yes.
quality than continuous, so it's just not guaranteed.
Yeah, we'll go through these in some detail. DDX, what would we like to look at here? How about squared x.
Yes, the second is false. I just changed the position of sentence.
Yeah, these
Oh,
can be a little bit subtle. Let's do it. So the first one is false, right? Because the derivative of e to the pi,
They're constants.
right? E is a constant, pi is a constant, so e to the pi is a constant. Whatever, it's about 9. No, it's somewhere in that neighborhood. No, this is closer to like 27. Sorry, 7 is constant. The second one is also false, right? And we could think of this as a counterexample thing. So, for example, f of x equals the absolute value x is continuous at x equals 0, but not differentiable at x equals 0. What about the third one?
I believe it's true, if I remember correctly. I
Yeah.
feel like this is one where you just have to know it, right?
Well, I think this is true also, and there is some stuff that you have to know here. The reason I chose this very last one, and yes, Talia, I'll go back and look more closely at the second one in a second. The reason I chose this last one is because it allows us to practice the chain rule a little bit. So if I want to differentiate secant squared of x, how do I do that?
Secant x multiple secant x multiple tangent x plus secant x multiple secant x multiple tangent x.
So it sounds like, yeah, Yiping's suggestion there is coming from the product rule. So we could do this as a product rule thing. You could treat secant squared of x as secant x times secant x and apply the product rule. My suggestion would be to do this as a chain rule thing. So remember, secant squared of x is secant of x all squared, right? So I do have an inner and an outer function. The inner function is the secant here, and the outer function is the square. So my inner function is secant x, and my outer function is like u squared. So if you want to call this u, then this is u squared, where u is equal to secant x. So you would differentiate the outside, leaving the inside alone. That means I'm going to differentiate the square like this. And then I would need to multiply by the derivative of the inside. So this is a 1, not a prime here. Be clear about that. And then we multiply by the derivative of the inside. This is a prime. So that would be 2 secant x times the derivative of secant x, which is
Secant x tan x or something.
exactly secant tangent. So this is 2 secant times secant is secant squared x, and tangent is tangent x. So these are all examples of questions that I have put on this first exam in Calc 1 in the past. We wanted to look a little bit more closely at number 2. So there's a few ways to kind of get yourself through this one. And the fast way is to remember precisely what Sarah said, that differentiability is a strictly harsher condition than continuity. So this question is trying to catch out a misconception. the misconception that this is kind of trying to look for is all continuous functions are differentiable. It's not true. Right? It's not true. And the absolute value function is kind of our prototype or easy to work with example of a continuous function. It's continuous everywhere. That is not differentiable everywhere. So the absolute value function looks like this. Remember his graph. And he's got this sharp point down here. The graph is pointy. At x equals 0. So f of x equals absolute value x is not differentiable there.
Question. So with the pointy thing, I know that means like you can't make a tangent line there.
Right.
Is there like, so you know how for continuity, if the limit of f of x as x approaches a equals f of a, it's continuous.
Correct.
So is there like a similar thing like that for differentiability?
Yes, there is. So if you want the strict definition of differentiability, independent of like, is the graph pointy? Remember, and this is a useful thing, definition, we say f is differentiable. I'm going to continue to abbreviate that as diffable, if that's okay with you, at x equals a, if and only if. It's not very satisfying. It's the limit defining the derivative, right? So if the limit as h goes to 0, f of a plus h minus f of a all over h exists and is finite. So if the limit that defines the derivative f prime of a exists and is finite, then we say that the function is differentiable. This is kind of the equivalent statement there. And it happens to be the case that if the graph is pointy at x equals a, then this limit won't exist. The left and right limits will be different. For that particular function, if f of x is the absolute value of x and a is 0, then f primed of a would be the limit. That's h. It's the same thing I'm writing, but I wrote above, f a plus h minus f of a over h, which for this function, if you plug in 0 for a, you get absolute value of a plus h minus absolute value of a over h. And then you plug in 0 for a. This is just the absolute value of h over h. And that limit does not exist based on the one-sided limits. If you look at the lim h to 0 from the left, absolute h over h, what is that? Well, since h is less than 0, right, I'm sneaking up on 0 from the left, the absolute value of h would be the negative of h. Oops, I need to write my limit, sorry.
I cannot understand how did you get the limit limit h approach 0 and the absolute a plus h minus absolute 8 over h is equal to limit h approach 0 and the absolute h over h. Where is the a? I cannot understand.
I'm taking this guy, I'm putting it in here. So we're trying to look specifically at the point where x is 0, where a is 0. We're asking, is this function differentiable at 0? So I need to look and see whether this thing exists for this function and this value of a. So to go from here to here, I'm just plugging in 0 for A. So if I plug in 0 for A here, then this is 0 plus H, which is just the absolute value of H. And if I plug in 0 here, the absolute value of 0 is 0. So this piece goes away completely.
Why is that just the absolute value of H if it's 0 plus whatever H is?
Oh, well, what is 0 plus H? It's just H, right?
Yeah, but I mean, couldn't H be negative or?
Definitely H can be lots of things, but here, let me put it this way. F primed of 0 is f of 0 plus H minus f of 0, which is the absolute value of 0 plus H minus the absolute value of 0. Now, what is each of these things? The absolute value of 0 is just 0, so this piece is gone. The absolute value of 0 plus H, all I'm going to do is simplify inside. 0 plus H is just H. So the absolute value of 0 plus H is the absolute value of H. Does that help?
But why couldn't we just call it H then? Do we have to call it the absolute value of H there?
Oh, well, yeah.
Because if from the left side is negative, from the right side to 0 is positive. So because left side and the right side is not equal to each other, one is left side is -1, right side is 1. So this one is continuously, but it's not differentiable.
Right. So I think to get more specifically at the question there, why can't I just call this H? Well, remember the absolute value of something isn't just that thing, right? The absolute value of H is going to be positive all the time, regardless of whether H is positive or negative. So here's the definition of absolute value, right? The absolute value of some stuff, I'm using the symbol U here so we don't confuse it with any of the other symbols. The absolute value of some stuff is just that stuff, if that stuff is greater than or equal to 0. But it's the negative version of that stuff if that stuff is negative, right? So what does absolute value do? If you're positive, it leaves you alone. If you're negative, it multiplies by another negative to make you positive. Right, that's why the graph of the absolute value has the shape it does. Slope -1, slope +1. Slope -1, slope +1. So then, like Yiping's saying, if we take this limit and look at the one-sided cases, if I send H to 0 from the left, that means H is negative. This means H is negative, right? Because we're going towards 0 from the left. If you're to the left of 0, you are a negative number, which means the absolute value of H is going to be negative H, because if you're negative, absolute value multiplies by another negative to make you positive. That's the definition. And so this first guy, the limit as H goes to 0 from the left is -1. On the other hand, the limit of this difference quotient as H goes to 0 from the right well, here H is positive, so the absolute value of H really is just H. And in this case, we can cancel and we get 1. Since those two one-sided limits are not equal, the limit as H goes to 0 of f of 0 plus H minus f of 0 all over H does not exist. And this thing is f prime of 0, i.e. f prime of 0 does not exist. So f is not differentiable at x equals 0. So if you had to go, if I told you to show me or prove that this function is not differentiable at x equals 0, this would be the work. Mostly this and this. But I think it's a lot easier to argue from the graph. And if you want to see how the two relate to each other, that is not bad. So here's 0, right? Here's the spot where I'm looking for the derivative. If h is negative, so h is going towards 0 from the left, what does that secant line look like? Well, that secant line would be this. Right? And as h goes to 0, this secant line stays the same slope, which is -1. On the other hand, if h is positive, if I'm letting h go to 0 from the right, here's that secant line. His slope is always +1. All right, so there's the limit that would define the derivative should be the same from either side. But as we come in from the left, as we send h to 0 from the left, we're getting this -1. That's the slope of this blue dashed secant line right here. This is the point that moves. This is the point that stays fixed. As I move this point closer and closer and closer to the origin along that graph, the blue secant line stays with the same slope, always -1. On the other hand, as I'm taking the limit as h goes to 0 from the right, this is the point that moves. This point stays fixed. As I drag this point inward, that slope is also always the same, always +1. So these two limits are not equal to each other. So feel a little better?
I had a couple of times when I was doing graphs while like just doing the homework, and I would end up graphing something that looked like a point because of the way that, because when I just kind of listed points is how it ended up looking, and it turns out it wasn't a point, it was just like a tight curve.
Mhm.
How do I know which types of functions will get me points and which ones won't? Is there like a list that I can kind of know?
It's a good question. Certainly, absolute value functions tend to have these sort of cusps here. So we do have a theorem. Let me remind you the theorems we have related to this. So all polynomials are differentiable everywhere. And any algebraic combination, how do I say this? Some difference product or quotient of polynomials are differentiable everywhere in their domain. And that last bit I have to include just because of the quotient, right? If you have a ratio of two polynomials, like a polynomial divided by another polynomial, that thing will be differentiable everywhere it's defined, but it's not defined where the bottom is 0.
Okay, thank you. And so you're also just with quotients, you're also just in general bringing rational polynomial functions.
Yeah, ratios of polynomials, rational functions. Other functions that are differentiable, are everywhere differentiable. On their domain include exponentials, trig functions. Logarithms, although we haven't worked with those yet. And again, any sort of reasonable combination of these. So if you take an exponential and a polynomial, you add them together, that will be differentiable everywhere. Or if you take a rational function and add that to a trig function, that will be differentiable everywhere that it's defined, that sort of thing. So some examples of functions that are not differentiable. Functions with differentiability issues include, of course, absolute value functions at the cusp, x equals 0. You know, you can slide these around, right? Like the absolute value of x minus 7 isn't going to be differentiable at 7. X to the 3 halves, x to the 5 halves, x to an odd integer over an even integer. These in general will have cusps at 0.
Are there derivatives of logs in the test?
No, not on this.
Okay.
No, yeah, so we haven't gotten to those yet. Other problems, if I have something like x plus 1 times x minus 3 over x minus 3 times x plus 2, something like this. This is not going to be differentiable at x equals 3 or -2, because it's at -2 you have a vertical asymptote. And at x equals 3,
It's undefined.
you have a hole. Yeah, it's undefined at both -2 and at 3, but they're kind of different ways of being undefined, and either of those would make you not differentiable. Specifically here, this last example, you're not continuous at -2 or at 3, and that's where that other theorem is useful. If you're not continuous, you're automatically not differentiable. These are the ones that jump out at me right away. If we want to include stuff like this here too, I can say also like tangent x at any odd multiple of pi over 2 for the same reason. Vertical asymptotes. Can you close the back door there? Actually pops open. So these are the sort of, usually when you run into a differentiability issue, it's going to be also a continuity issue. So most of the time, if a function isn't that we're working with isn't differentiable at some point, it's because it's not continuous there. But you do also need to watch out for these first two sort of things, where you are continuous, but you're not differentiable. So the latter two things here, this is more common for us, right? And that's why most people start thinking, oh, maybe all continuous functions are differentiable. But these provide good counterexamples where you are continuous, but not differentiable. All right. Do we feel a little better about this? Yeah, go ahead.
Yeah, for sure. Could you just repeat? So tan x at x equals, there's something in the parentheses. What does that say? Sorry.
2n plus 1 times pi.
Oh, so all iterations of that.
Yeah, all odd multiples of pi over 2. So like if this is pi over 2 and this is 3 pi over 2 and this is 5 pi over 2, the tangent graph has vertical asymptotes at all of those. Because cosine is 0 there and tangent is sine over cosine. Also like negative pi over 2, negative 3 pi over 2, and so on. Here's what tangent looks like.
Why is 2n plus 1 multiple pi over 2? I remember the tangent is pi is the period.
it's true that pi is the period. Can anybody help us out with that? What's that 2n plus 1 times pi over 2 saying? Can anybody connect that to the graph I'm drawing below?
So if I remember correctly, so pi over 2 itself is that's where you'll get the first vertical asymptote.
Mhm.
And then you have to count for, because tangent's kind of unlimited, so you have to count for all the other ones before and after it that will also end up in the same essential situation. So that's where 2n plus 1
Yeah, that's
counts
the
all of
idea.
those.
So this vertical asymptote right here at positive pi over 2, he's coming from, sorry, n equals 0. Right? If you plug n equals 0 into this, then you'll get this guy, because that's 1 times pi over 2. This guy is coming from n equals -1. If you plug -1 in for n here, this becomes -1 times 2 times -1, which is -2, plus 1 is -1 times pi over 2. So that's negative pi over 2. This guy comes from n equals -2. If I plug -2 in for n here, then this piece is -3. So that's -3 times pi over 2 is -3 pi over 2. This guy is coming from n equals 1. This guy is coming from n equals 2. So this is just a general formula for all the x values where cos x is equal to 0, which is the same as all the x values where tangent x has a vertical asymptote. So it's just a nice, neat formula. It's a way to write down, like Sarah said, the tangent function has infinitely many vertical asymptotes. So if I want to write them all down in one place, we need to do this sort of thing. So you see this in trigonometry when solving trig equations. This is the solution to the trig equation cos x equals 0. Right? Tangent is sine over cosine. So tangent will have a vertical asymptote everywhere cosine is equal to 0. And if you solve the equation cos x equals 0, this is what you get.
So actually 2n plus 1 multiple pi over 2 is the same n multiple pi plus 2 pi over 2.
Let me see. So n times pi plus pi over 2. Yes, it is. Yep, we could write it that way as well. And here, the reason Yiping's thinking like this, she's using the periodicity, right? So you know tangent is undefined at pi over 2, and you also know that tangent has period pi. So you take pi over 2 and add any integer multiple of pi to that, and you'll get all the places where tangent is undefined. Yeah, that's correct. Okay, any other stuff that we want to address related to differentiability or continuity?
No, thank you. That really clears it up for me.
Okay, while I'm here, because it was said but not written down, the definition of continuity, which is something I could ask about. F is continuous at x equals a means, or if and only if, the limit as x approaches a of f of x is equal to f of a. So the function value is the same as the value of the limit. That's what it means to say the function is continuous at that number. And then the theorem we already stated, right? If you're differentiable, then you're continuous. At x equals a, f is diffable at x equals a implies f is continuous at x equals a. That's true. But f continuous at x equals a does not imply that f is diffable at x equals a. And there's ways to turn these around, like that first one. you could read this also as if f is not continuous at x equals a, then f is not differentiable at x equals a. So that's called the contrapositive, which is different from the converse. The converse here is not true, but the contrapositive of a true statement is always true. All right, I think that's enough on this. Piecewise functions are our favorite examples of things to fuck with continuity about. So I can ask you to find the constant c such that this function is this piecewise function is continuous, that sort of thing, which we've seen in the homework. All right, let's get to the actual problems.
Piecewise function is continuous.
They can be. They can also fail to be continuous. It depends. So the thing to do with the piecewise function is to check this definition. We can look for an example, but let's get to the ones that people asked for specifically in the chat. I want to make sure we get through those. First one was from the 3.2 homework. We wanted to see number 5. Oh yeah, this is a good one. Okay. Let me write it down and then I'll switch back to the document camera. So what homework set was this? The 3.2 homework, what number was that? Homework 6. Problem 5. Differentiate y equals e to the p times p plus p root p. All right. So can I combine any like terms here? Can I add these two together? Is this like two?
You can pull out a P from both.
Yeah, we could factor out a P. We could factor out a P. So here's, share with you a little bit the way I encourage you to think of this. And it's going to affect the algebra steps we choose to do. So if we factor out a P from this, then this would be e to the P times 1 plus root P. And if I want to jump into that, it would require 2 product rules, right? Because there's 3 things multiplying together there. So that, well, it's a reasonable algebra step. And if we were just trying to simplify, I would say, yeah, factor out that P, that's nice. But because our goal here is to differentiate, I would like to minimize the number of rules I need to use.
You can do the
Product
exponent rules
rule.
and then add them together.
Yeah, there is some simplification that can be done here. So let me show you exactly what I would simplify before I differentiate. E to the P, I would leave. And then I would write this as P plus, this is P to the 1 times P to the 1/2. So when you add those powers, that's P to the 3/2. So I would treat it like this. I would call this piece my little f, and this piece my little g. So then y primed here is f primed times g plus f times g primed. That's the product rule. So what is f prime? Well, if f is e to the p, then the derivative of e to the p is just e to the p, because here my variable is p, times g. So I leave the other function alone, p plus p to the 3/2. And then I add that to what I get when I leave f alone. So it's just e to the p times the derivative of g. The derivative of p is 1 plus the derivative of p to the 3/2 is 3/2 p to the 1/2. So this would be an acceptable answer. It's not fully simplified, but this would be acceptable. If we want to clean this up, the easiest way to clean it up is to start by factoring out an e to the p. Nikita, I see your question there. I'll get to it in just a second. When I do that, this piece will be p plus p to the 3/2, and then I'll have plus 1 plus 3/2 p to the 1/2. And there are no like terms that we can combine there. You could, there's stuff you could do, but not much. So I would leave it like this, or leave it like this. Now Nikita had a question in the chat. So on the test, it's easier to change my variable to X to see it better. Am I allowed to do that? I'll put my answer with all the correct variables. The actual step I'd like to have in a different variable. So here's the thing. Later, we're going to be using different variables to represent different things. Like I'm going to use X for position and T for time in the same expression. So if you were to try to change all the T's to X's there, you could get in a lot of trouble, right? You might end up thinking two things are the same variable when they're not. It's not going to hurt you on this test, but it could hurt you badly on the next test. I will not take points off if you change the variable to X when you write things down on your test here. However, I caution you against it strongly, right? Like, well, we don't want to develop bad habits. I just leave it at that, right? So I would say changing all the independent variables to X in your own paper, while understandable at first, is kind of a bad habit, and I wouldn't want to encourage it. But on this test, I won't be taking points off for it. Just be aware that on future tests, it will get you in trouble, not because I'm going to be like shitty and take points off, but because there will be problems where both of those variables are involved or multiple variables are involved, and you could confuse yourself. So I won't penalize you for it, but it can get you in trouble down the road. All right. Other ways we could approach this problem, you could distribute the e to the p and write it as e to the p times p plus e to the p times p to the 3/2, and then do a product rule for each of those. But I think this is much nicer. Any questions on this problem? Okay, it looks like 11 and 17 are the next two ones that people asked about. Let's see, and I see a question about when the review is due or when the study guide is due. So both the study guide and the chain rule homework are due on Wednesday. And that is a change I made. So when I first posted the study guide, remember, we didn't know when the test was going to be. We posted the study guide early. So I put the original date in there as Friday. But after we set the date of the test last week, I changed the study guide's due date to Wednesday. So please be aware, the study guide is due on Wednesday. I changed that last Wednesday when we set the date of the test. So last Monday, when I originally posted the study guide, it was set to be due on Friday, but I changed that to the date of the test. And that's generally how it will go. The study guide is always going to be due on the day of the test, because you're supposed to do it to prepare for the test. All right. Speaking of the study guide, 11 and 17.
And also I have a questions in the exams. How many times can I submit the answer?
On the test, just once. So the test is not in WebAssign. The test, let me show you here. I can show you a test from my Calc 2 class this morning, in case I haven't shown you already what the format of the test looks like. Here's what your test is going to look like. All right, it's in Canvas, and we can answer each question only once. So this was the test I gave my Calc 2 class this morning. These are the free response problems. So you'll type just your final answer in the box, and you'll show all your work on your paper. And definitely we just have one attack at this. It's just like a regular test, like you would do in class, only it's on Canvas. All right.
The 3.3 and the 3.4, they're on the exam, right?
Yes, 3.3 and
Okay.
3.4 are both on the test. Yep. Okay, number 11 here. We want to find this limit. Does anybody know what tool we need to find this limit?
How you do product rule?
Well, I'm not looking for a derivative here. If I was trying to differentiate that function, that would definitely be a product rule and quotient rule thing. But this is an earlier problem. This is just a limit problem.
Oh, you take the limit of them separately?
That would be a good way to start. What happens if we do that?
I change e to minus 4x, change it to the e to 4x, 1 over e to 4x. So when the x is approach infinite, 1 over e to 4x is going to 0.
That's true. So the suggestion here is to try splitting it up, right? The limit as x goes to infinity of e to the negative 4x, and then I'll do what you said, Yiping, with that, times limit x to infinity of just the cosine.
I think it's used the sandwich theorem, Screech theorem.
Yes, that's very
Cosine.
good. So let's back up for just a second and make sure everybody understands why. So what Yiping said at first there is correct. We can treat e to the 4x, e to the negative 4x as 1 over e to the 4x. And then we still have this lim x to infinity of cos x on its own. The first piece here, this is 1 over infinity, because e to the 4x goes to infinity as 4x goes to infinity, which would be 0. But what is the limit of the cosine function as x goes to infinity?
X approach infinite, cosine function undefined. D and E not exist.
Very good. The limit of the cosine function as x goes to infinity is a dne. Cosine just wobbles back and forth like this forever and ever, right? It never settles down. So this piece is a dne. So what I have here is 0 times dne, which is what again?
0.
Well, in this case, it's going to be 0. But in general, that's not true. So in order to find this limit, so the question,
D and E.
yeah, this on its own doesn't tell us anything. And so we need the squeeze theorem. And getting a limit out like this, getting like 0 times dne, is a good hint that you need the squeeze theorem, or sandwich theorem, or policeman theorem, whatever you like to call it. The way we would begin with this is by observing, or recall, that the output from cosine is always between -1 and 1. Right? The cosine function is a bounded function, and that's what makes this work. And then from here, we can multiply through by e to the -4x. So I'll get negative e to the -4x is less than or equal to e to the -4x cos x is less than or equal to e to the -4x. And we know the limit of the outer functions, lim x to infinity, negative e to the -4x is equal to 0, as is when x to infinity, e to the -4x. I'm going to say and. Right, and each of these, this guy is coming from what we know about exponential functions. E to the -4x, that's a rapidly decaying exponential. His graph looks like this. So as we wander further and further off to the right, he's going to 0. And the negative of that is just this flipped over vertically. So he also goes to 0, or you can think of it like the negative pops out. Therefore, by the squeeze theorem, the limit of the function in the middle must also be 0. So right here, everything after the recall is what we need to solve this problem. This would be a complete solution here, 10 out of 10. Radha, yeah, if you type an answer in the box, but you haven't submitted the test yet, you can go back and change it. Those forms all stay open. It's not like one question at a time. Now, I advise you, because of that, some people wait till the very end to type their answers. Don't do that. Because if you forget to type an answer in the box, I can't give you any credit for that question. So I'd say solve the problems, whatever order you want to. What I suggest is picking out the ones that look easy to you, do those first. But whatever order you do them, as soon as you solve a particular problem, type the answer for that problem in the box, then move on. Don't wait till the end of the test to go in and type your answers, because if you leave an answer out, if you forget one or you run out of time, then I can't give you credit for those questions where you didn't type anything.
If I submit answers one by one, will I know that it's correct or wrong at that moment, at that time?
No, not until you've submitted the test. Once you submit the test, it will tell you which true false you got right and which multiple choice you got right. And then it has to wait for me to grade all the free response questions. Okay, any other questions or comments on this problem, this limit here?
I almost never think intuitively to use the squeeze theorem. What hints, like you mentioned, the 0 times does not exist is what told you to use the squeeze theorem here. Are there any others like that?
Yeah, so this piece is bounded. And this piece goes to 0. That's sort of your general recipe. So if you have a bounded function, a function whose range is finite, times a function that goes to 0, those are always good candidates for the squeeze theorem. In fact, if you have a bounded but badly behaved, so if you want to know in general, when do we use the squeeze theorem? Well, if you're looking at lim x to somewhere, and you've got a product of two functions, if one of them is badly behaved near A, and the other is bounded near x equals A, this is a strong hint. And we'll probably use the squeeze theorem. So if you can think of your limit as a product of two functions where one of them is doing something shitty and the other one is doing something not shitty, then probably the squeeze theorem is your friend. Yes, Radha, those are things we need to know. Yeah. So we definitely should know the range of sine and cosine, all of our standard functions. We should be able to picture their graphs and know what their ranges are and their domains. Badly behaved can mean oscillating quite wildly. It could mean a bunch of different things, but basically if the limit of one is a DNE or really hard to find, and the limit of the other is really nice, then probably the squeeze theorem is going to help.
Thank you.
Of course. We wanted to look at number 17 in the study guide as well, right? 17. How many oh yeah. This is a lengthy one. So I don't know if I'll have time to do all of this, but I can do my best here for you.
There are office hours today, right?
Yes, sir. So I don't know how many tangents to the curve y equals x over x plus 3.
You have the little tab open covering the
Hey,
screen.
yeah, I know. I just got to write the thing down first. I'll
Oh,
skip
okay.
just a second. And where are these points of tangency? Alrighty, so here's how I approach this problem. First things first, I would look at the graph of x over x plus 3. If you don't remember how to graph stuff like that, this is something that I'm supposed to assume you know from pre-calculus. But because graphing rational functions is something people tend to struggle with, there is a review thing in the modules here, graphing rational functions. Right, so being able to cook up a graph of a function like this without any bullshit is really nice. So we should be able to do this, right? We should be able to sketch a graph like this without using any calculus, just using our knowledge of pre-calculus algebra. And this is certainly a nice example of one of those. X over x plus 3 is a rational function. No common factors between the top and bottom. But if you scoot out to the left 3 units at x equals -3, the bottom is 0. The top there is not 0, so we're going to have a vertical asymptote. The degree of the top and the bottom, they're both linear functions, both degree 1. So to find the horizontal asymptote, we would take the ratio of lead coefficients, which in this case is 1 over 1. So our horizontal asymptote is the horizontal line y equals 1. Other stuff we know about this, the top is equal to 0 when x is 0. That means we have an x and y intercept there at the origin. And I know I need to approach this horizontal asymptote from below because I have to be coming from this point. So I can say, okay, we're going to do something like this. Which means up here, we're going to do, I'm going to draw it here, and it's nasty looking, something like this. So this purple is a reasonable graph of this function. It's not carrying all the information in the world, but it's good enough for what we want. Where is 1, 2? Well, here's 1, here's 2 on the y-axis. So right here is the point 1, 2. Now, if you start asking yourself, where could I have tangent lines that touch this thing? Well, start trying to sort of draw a line from that point to somewhere on the graph such that the line is tangent. So I'm seeing one here. So I suspect there's a point where the tangent line goes through 1, 2 here on the graph. And then from the other piece over here, let me see. Something like this. So it looks like there should be 2 points on the graph that give me a tangent line through 1, 2. That's the answer to part A. Part B here, they want you to find those points. So the big step for this is the tangent line to y equals f of x at x equals a always follows a certain form. It is always of the form y minus f of a equals f primed of a times x minus a. Right, it's the point slope thing. The point has to be a comma f of a, because a tangent line touches the graph at x equals a, and the point on the graph is a comma f of a. The slope has to be f primed of a, because that's the definition, right? The tangent line is the line passing through that point with slope coming from the derivative. So if you take these things, this point and this slope, and plug it into your point slope formula, you get this. So what you're going to do now is cook this up for this function in general, in terms of a. For us, the point is a comma f of a, which is a comma a over a plus 3. And the slope is f primed of a. So what is f primed of a for this? Well, f primed of x is the derivative of x over x plus 3, which we can calculate using the quotient rule. It's the bottom times the derivative of the top, x plus 3 times 1, minus the top times the derivative of the bottom, that's x times 1, over x plus 3 quantity squared. The x's cancel, right? You get x plus 3 minus x. So you just get 3 over x plus 3 quantity squared. So f primed of a is 3 over a plus 3 quantity squared. Therefore, your tangent line is a general tangent line to the curve y equals x over x plus 3 looks like, I just plug these things in. Y minus f of a. Well, f of a is a over a plus 3. Right? In other words, I'm using point slope, but this is my y value, equals f primed of a, 3 over a plus 3 quantity squared, times x minus a, which is just x minus a. So here is your general equation of a tangent line for this curve. If I want this tangent line to pass through the point 1, 2, to find when, i.e. for what a values, this passes through the point 1, 2, plug x equals 1 and y equals 2 into the equation above, and solve for a. All right, that's your recipe here. Now this problem, like I said, this is the hardest problem on the study guide almost for sure, and it's definitely more involved than a problem I could put on your test. It requires too many creative steps. There's too much going on here for this to be a single problem on the test. But solving problems like this is really good for you. I remember solving this very problem in Calc 1, and it was a fun experience. So my advice for you would be, if you haven't solved this problem yet, to approach it fresh. Approach it fresh and try on your own. Draw the graph, try to get an idea for this x value and this x value. Then cook up your general tangent line, right? This is your general tangent line. Every tangent line looks like this. The trick is the point of tangency, a comma f of a, is not known. In fact, that's what we're looking for. We're looking for these 2 points of tangency that give us tangent lines going through 1, 2. So we don't know what these points are yet. We have a rough idea of where they are from the picture, but we don't know what a is. So you just leave a as a. You leave f of a as f of a. What is f of a? Well, it's a over a plus 3, because f of x is x over x plus 3. Calculate your derivative. And remember, the slope of your tangent line is f primed of a. So your slope is going to be that derivative with a plugged in, not x. That means your general tangent line looks like this. This is the point slope form of a line whose slope is 3 over parentheses a plus 3 squared. And the point is a comma a over a plus 3. That's a point on the graph. So you know that every tangent line to your curve looks like this. And the question is, what tangent lines pass through the point 1 comma 2? In order for any line to pass through the point 1 comma 2, you should be able to plug 1 in for x and 2 in for y and get a true statement. So to find out when this line passes through 1 comma 2, you plug 1 in for x here, 2 in for y here, and then solve for a. All right, it's a good problem, and you now have all of the hard parts. So if you haven't done this on your own yet, please go try to work through it on your own. But if you get stuck, come back, look at these notes, look at the video, and you'll be able to get through the rest of it. I promise it's not hard. All right, we know we're looking for 2 answers. We know we're looking for 2 a values. Each one of those will give you a point.
You said solve for a there. So like if you're solving for a and you can't solve for a, it means there's like that there's like not a point, or like what does it mean? Or is
Yeah,
that
good
not going to
question.
happen?
So remember, first we have to plug in 1 comma 2 for x and y,
Hmm.
right? So you got to plug
Yeah,
in.
what I'm saying is like, say you get like a thing where it's like, I'm not saying it's gonna happen in this exact one, but it's like a equals 2, or like a equals, I mean, I can't even think of it right now.
Oh, sure, a equals
Like a
over
equals
0.
x squared, a equals a squared or something like that, for example.
Well, a equals a squared isn't a problem. You pull everything to one side and factor. But I know what you're asking. If you plug those x and y values in here and you get an equation that cannot be solved for a, that would imply that there are no points on this graph whose tangent line goes through 1 comma 2. That would be the result there. So if you got something like a squared plus 1 equals 0, right? There are no real numbers that solve that equation. So we would discover from that there are no points on this purple curve that pass through the point 1 comma 2. This will yield 2 solutions for a. This, after you plug in for x and y, would become a rational equation in the variable a, which when you clean everything up will have a quadratic numerator. So yes, you're going to get two answers for a there. Fastest way is multiply both sides by a plus 3 squared. That'll clear out all your denominators. Just remember, a can't be -3, but a can't be -3 anyway, because we have a vertical asymptote at -3. So yeah, fastest way to solve this after plugging this info in is to clear out those denominators. Multiply both sides by this term. That'll knock out this denominator. It'll also knock out this one. And what's left is going to be a quadratic in the variable a, which will have 2 real number solutions. If I remember right, they're not necessarily nice. I think they were pretty gnarly irrational numbers in the example I worked. All right, I do think we're about out of time here. Yeah, we're in fact a little bit over time, right? So I'm going to go ahead and end the meeting here. If you do get stuck on any of those other study guide problems, you can come talk to me in office hours. I'm going to be looking through your study guides a little later tomorrow afternoon, and I'll give you feedback on them. So, you know, if this were on a test, this would be a half-point mistake, so on and so forth. But if you want to talk before then, you can come by my office hour this afternoon. Remember, look at your schedules and make your plan for whether you're going to take the test at the testing center or online with me. If you take it at the testing center, the only catch is there's no guarantee you get to take it right at 11. You might have to wait. You might have to wait 5 minutes, might have to wait 30 minutes, and that could mess up the rest of your day's schedule. So you want to plan around that. Any other questions for me? All right. Oh, I did just remember there was one chain rule thing I wanted to show you guys today. Let me show you this before we go. One last chain rule thing. So we know how to differentiate e to the x, but how do you find the derivative of 2 to the x? Or in general, the derivative of b to the x, where b is not the same as e. The trick here is that b to the x is the same as e to the natural log of b to the x. In fact, anything is e raised to the power of the natural log of that thing. And then by the rules for logarithms, I can write this as e to the x times the ln of b. So, and if you want, you could write this as e to the ln of b times x, like that, with the x outside the log. So the derivative of b to the x in general is the derivative of e raised to the natural log of b, which is a constant, times x. And this guy, by the chain rule, so my inner function here is ln b times x, and my outer function is the exponential. So this is going to be e raised to the ln b times x, differentiate the outside, leaving the inside alone, times the derivative of ln b times x. What is the little derivative here? Remember, this ln of b is just a number. It's a constant.
Is it just b?
Almost. So if this was like 5x, then the derivative would be 5. If this was like pi over 2x, then the derivative would be pi over 2. Since it's ln of b times x, the derivative
ln of b?
is ln b. So this is e raised to the ln of b times x times the ln of b. And then e to the ln b times x, you go back through this process and you see that that's just b to the x. So b to the x times the natural log of b. That is your general derivative. So it's like e to the x in that you get the original function back, but if the base isn't e, you have to multiply by the natural log of that base. So for example, the derivative d dx of 2 to the x would be 2 to the x times the natural log of 2, and so on. Alrighty, that really is everything I wanted to share with you guys for the day. So I am going to go ahead and end our meeting here. If you want to come by office hours, that starts at 1 p.m. If you got anything else you need to talk to me about, you can send me a Canvas message. Please make arrangements for your test. And if you need help with anything, don't hesitate to reach out. All right.
Do you have homework today?
No new homework opening today. No, just use today and tomorrow to get ready for the test on Wednesday.
Okay.
All righty, guys, take care.